Shall we start? Shall we start or wait for another 2 minutes? So now we are 40 minutes. Okay. Okay, shall we start now? Okay. Welcome back to the virtual material testing lab. We have been discussed about some experiments which are comes under the minor experiments. Particularly, we have been gone through 3 experiments for particular applications. That is harness testing. So we, being in mechanical engineers, we need to know the hardness value of the given engineering materials. The number of engineering materials are available across us. So we need to take them to produce the different kinds of the engineering components, so that before going to or before selecting, or that the selection criteria will be depending upon the behavior of the engineering materials. So that we need to know the thorough behavior of the engineering materials. Means thorough mechanical behavior of the engineering materials. Each and every material possesses the number of mechanical behaviors. In that we need to discuss the harness. So one, that the main number of mechanical properties that material does, and that will sometimes that will give the good results for particular behavior. Sometimes that will give the normal values or normal results for the particular property. Let it be, no problem. But hardness is also one of the major mechanical behavior of the engineering material. Hence, we all together conduct and we all together to know the what exactly the hardness value of the engineering material, how it's important. Definitely we want to make something, you want to construct something, definitely that engineering components or that engineering element should resist some loads or initial loads, or that should have some physical stability to resist the environmental attacks and any other normal loads which are acting on the surface. At least that surface should be resist a certain amount of loads, that initially that we can call it as hardness. Hardness is one of the physical property. If we can say that material has a good physical stability, hence mean that the hardness value of that material will be the good, right? This is the phenomenon. This is the reason now we are going to conducting the hardness value of the given samples. In that, suppose if you want to conduct the hardness number of that particular engineering material, here we have 3 different methods, which all the three methods are very important. I told you that we have to have the practice of all the 3 experiments, all the 3 machines, experience about all the 3 machines, and also the procedure and everything. We have to have that information and that practice. We need to conduct all the 3 experiments, so that we are already gone through simulation about Rockwell harness, Brinell harness, and Vickers harness also. How Rockwell harness testing is performs, and how the Vickers and Brinell machines are performed. So what will be the parameters, and how we need to select the parameters, and how we need to control the machines. All the parameters: load, scales, selection of material itself, dwell time, minor load, major load, all these are activities are very, very important. These are the practical activities. We make ensure these activities while conducting the experiment. Also, we have to have the information regarding this, what exactly they all does. So this will be helpful for your the final examinations. I hope you are understanding how these machines are practically does, that we can able, that we can able to understand through the simulation. Already we have been gone through the simulation. I hope you understand how these practically they are works through the simulation. So already we have discussed all these things. Now I will take you into the next experiment. Today we are planning to conduct the impact test. So this is also one of the major test. We need to know the impact value of the engineering materials, because then only we can able to suggest these engineering materials to the particular applications. Some applications, before going through this experiment, I would like to share you with you why we need to conduct this impact test, what exactly the impact loads are. Because here we need to apply the load in harness. You can just, you might have observed, I think in harness we are applying some downward force loads, right? In harness we are applying some certain type of certain mechanism, certain principle which we can adopt to apply the external load over the sample. In impact we are applying the load will be the different. The principle of applied load will be the different in impact. However, you can take a tensile, you can take a compression and bending. You know very well the different forms of loads, right? You know very well different forms of the loads. Our selected engineering material that should give the sufficient results when they are come across to such kinds of the engineering loads. It may sometimes it is come across to the, or come across, or it is when undergone to the or compression load. Sometimes it will come across the tensile, sometimes it is come across the impact load, sometimes it come across bending or torsional. So that particular material that will give the, whenever it come across such kinds of the load formations, that material will withstand and that will give the good results. Such kinds of materials we can, being an engineer, we are going to select and suggest to make something useful or to create something that for the useful applications, right? That's what here we need to understand what exactly the impact flow. Suppose that particular material has a good impact values or good impact results, then how can I utilize these kinds of the engineering materials? Where exactly I can fix this material, where exactly I can set these materials, what kind of the applications I can suggest these materials. That will be very, very important. All these things, uh, meanwhile the simulation we can able to understand through this lab. So now I will click on the IZOR, so impact test, and here in impact test, we have two methods or two procedures which we can able to perform. One is IZOR, other one is a Charpy. The main aim of this experiment will be the same, but the way of conducting the test is different, right? There will be the parameter difference in the both experiments. Hence, we can give the different names ICHOR and Charpy tests. But both methods or both the procedures will give the impact value of the particular sample, right? But in further we can discuss the what why we are taking the two methods and how these are important each. That I will discuss. The theory we already we have been discussed in our classroom. In this theory only we can able to define what exactly the impact strength of the engineering materials. Anybody wants to answer this, or can I expect the answers from you? What do you mean by impact strength? Hmm? What do you mean by impact strength? please?
Sudden load, sir.
Sudden load. Okay. Sudden load is acting upon the sample. Yes. Right. The ability of the material to resist the sudden loads or sudden shock. Sudden load does not mean only it is restricted to the mechanical loads. It's not only to the mechanical loads. Okay, sometimes it is a sudden temperature. The sudden temperature will be rise, that may causes or that may affect to the system or sample. Not only to the pressure, that is in terms of any message or in terms of environmental attacks, in terms of anything else, it may happen suddenly. Sometimes temperature also affected to the samples and system. Suddenly the temperature will be gone rise or suddenly gone down, right? That also affected to the system. So sudden changes takes place in the system, that also may affect it to the that affects or that may cause us to the certain mispart happens in the system. That also we can call it as an impact load. Here in particularly in mechanical build, now we are going to define the impact behavior of the engineering material, the ability of the material to resist the sudden loads, ability of the material to absorb the energy which is suddenly happens over the material. So that material have to have the capability to observe the sudden loads, right? So this the which means that we are expecting or we are looking that property in the engineering materials. Why we are looking this impact property in the engineering material, that will be the very important. Then only we can apply our mind to make something. For example, I would like to share here, so your vehicle, you might have observed the number of vehicles, the number of two wheelers, not so two wheelers, so maybe it's, four wheelers is the best example. So the front of the vehicle, there will be the, we can call it as a bumper, right? Yes, front of the vehicle there will be the structured part, the front of the vehicle. You can take the Mahindra vehicles, Mahindra four-wheel vehicles, right? Or we can take some tractors or some sports bikes and sports vehicles. There will be the bumper in front of the vehicle, right? Many of the sports cars having there is in front of the vehicle that has a bumper type of, but we can call it as a generally bumper, that is a structural part. So some people are what they are understanding, they understand this is just attractive purpose, just it is on covering purpose, that it is look like our vehicle should be aesthetically it look like good. So that they are thinking only the aesthetic point of view. This is for only the attractive purpose they are mounting the bumpers, the front of the vehicles. Actually, that is not that purpose. That bumper which is mounted in front of the vehicle, which is made by the high impact resistance material, right? Which is made by the high impact resistance material. So whenever the accident means sudden load it is. So we cannot expect when the accident happens. We don't have that facility in our vehicles. After 10 minutes, I'm going to hit somebody, or I'm going to hit some vehicles. Also, after sometimes some vehicles are come and hit to our vehicles. We don't have this much this kinds of the higher technology in our vehicles. We not yet creating the right. Nowadays that also we are creating the by using the artificial intelligence. Nowadays that KSRTC in government is already start using the some artificial intelligence devices in the vehicles, the government vehicles, so that we can understand the speed of the vehicle, and also we can control the speed as well as the accidents also. Now that's the with the help of the machine learning, artificial intelligence and machine learning. Now we are start using the adapting in a vehicle so that we can control the accidents, right? But In earlier days, what happens that the bumpers are the high impact resistance material that would have or that would that would have withstanding the more energy whenever we are hitting uh, to the walls, and then accident means it is accident, unexpectedly it happens. Yes? That bumper will absorb all the loads or energy, then that will protect our vehicles. Also human beings, human beings means the driver or any other passengers sitting in front of inside the vehicles. This is the reason now we are using the bumpers. Bumpers are completely made by the high impact resistance material. And such kinds of the applications also, this is the one of the domestic applications, or we can call it as automotive application it is. Automotive applications it is. Now sometimes in industry, in industrially also we need to construct our machines. Outer part of our machine should be high impact resistance. May sometimes casings, engine casings, the gearboxes, the housings of the gearbox, right? Any of the housing components which are high impact and high hardness materials. These kinds of the applications, we are looking the impact property in engineering materials. I hope you understand. I will not take much time to discuss this. This already we have been gone. We have been discussed in our theoretical classes. Just I am glancing the things here. Now I will coming to now one. Will show you here. This is what we can call it as an impact machine, right? This is the impact machine. By using this machine, we can able to determine the impact strength of the given sample, right? Now let's move on to the procedure directly. Yes, right. See, so here we can able to see the machine, right? Now so this is the first apparatus. Now step one. Now we can come into select the ISO test specimen. I told you that there are two methods. One is a IJOD, other one is a Charpy test. Is there? If suppose if you want to conduct the IJOD test, so where exactly these two are take the diversity or take the difference? Preparation of the sample. Preparation of the sample for the IJOD test is a different, and the preparation of the sample of the Charpy test will be the different. How can I identify the samples for the Charpy and IJOD? But most of the time the diameter and the size of the sample will be the same. Thickness of the sample will be both the cases will be the same. So square rod which we can use to prepare the sample by using mild steel material which we can use. But mild steel having a size is around all the sides are equal, means the square rod which we can use to create the required shape and size of the IJOD and Charpy test. Here you can see this is the myosteel material, which is a square rod, right? All the sides are equal. Is a 10 mm square rod. 10 mm square means all the sides are same. 10 into 10 myosteel material. Here we have a group, and total length of this sample will be the 55. Keep it in your mind. If you want to conduct the IJOD test, the total length of this sample will be 55. And thickness will be the 10 into 10, total size will be 10 into 10, total length will be the 55. And here we have a groove. You can able to see here the groove is there. Exact middle of the sample we need to make grooves, right? Exact middle means how much we need to measure from this end or this end. Which end we want, you can take it. The how much we will take. Exact middle means from here to here how much we need to take. Exactly middle. This is total length of this sample will be the 55 mm. Now exact the middle of the sample we need to make a groove. Sorry, this is I think it's not Charpy, it is IJOD test. So IJOD test means 75 mm length. Charpy is a 55. This is the IJOD test. Sorry, don't get confused. The IJOD test. This IJOD test here we have a 75. So the people are mentioning the 76, not 76. Exactly the 75 mm. total length will be the 75 mm. So they are making a groove here. They are showing the exact middle, but actually the ISO test here we can take the 25 mm out of 75. Here you can measure from this end to 25. So exact, which means 75 portion. So 75% portion will be the inside. Only the 25% will be the so outside whenever we are conducting the experiment, because we need to insert this ISO sample in vertically. So this entire 75 portion will be into the machine and only 25 portion will be exposed to the pendulum. Hence we need to take the from here to here there will be the 25 mm. Remaining the thing will be inside the machines. From this end to this, total length of the sample will be 75. From here to here there will be this will be the 25 mm. At exact 25 mm you can make. So how to construct this? You only can select the square rod, then you can cut exactly 75 mm length of the sample. Then you can measure from this end to 25 mm. Here it will be the 25 mm. From here to here this is 25 mm. Once you got the 25 you can mark it or you can indicate it. Then you can take hexa blade, then you can create the grooves. Groove depth will be the 2 mm. Keep it in your mind. In the prior examination definitely can ask you what will be the groove depth. The groove depth will be the 2 mm, right? And this will from here to here is a 25. Remaining rest of the thing will be in the inside or below. I think it is 60 plus. Sorry, it is 50 plus 25 is a 75. So the groove depth will be the 2 mm. Exactly 2 mm we need to take, or we need to take the hexa blade and then we can start cutting this. This depth will be the 2 mm. Hope you understand. Total length of the sample will be 75, and the groove, here we are making a groove to measure the 25 mm from the end we need to measure the 25 mm. So where exactly 25 mm so we can note on it and we can indicate that with the help of the chalk piece or anything else we can take to make that indications exact that 25 mm. Here once we are measure it, then that point we need to groove it. That groove will be the 2 mm. Don't exceed more than the 2 mm. If you exceed the more than the 2 mm, that procedure will be the wrong. So according to the ASTM standards we need to follow exactly groove depth will be the 2 mm. This is what preparation of ISO test. Keep it in mind. 75 mm length, overall length of the sample will be 75, thickness will be the 10 into 10 and groove depth will be the 2 mm. Right, now we need to move on. But here there will be the different parameters. Either you don't take these parameters. These are according to the NITK Surathkal. So according to our laboratory, I am telling you that only these parameters will be varies. The remaining thing will be the same. Only these parameters will be changed according to our VTU syllabus and our what we have in our laboratory. That I can tell you. So 75 groove depth is 2 mm. So this is the milestone material which we can take in our laboratory. That's what I understand. Now once we prepare this sample, here we have a sample, then go for the next step. Next step is the test for the friction loss is conducted by adjusting the pointer to 164 joules and the hammer attached to the pendulum is released by operating the lever without keeping the specimen. Okay, that also I will explain. See here, this is one type of the calibration process. I hope you understand. It's one kind of the calibration process because here we are keeping these machines since from months or since from 4 months, since from a year we are just keeping the samples. So because once the third semester is over, we have at least we have a gap of between 2 to 3 months. 2 to 3 months. Since 2 to 3 months we are keeping that machine idle. Hence there will be the environmental impact and there will be the residual stresses, or else sometimes we are working on these machines. After the work done also there will be the load present in the machine. Right? Suppose you are applying some we are conducting the ISO or Charpy test, you are releasing the pendulum, hence there will be the load will be offered or generated in the machines. So that everything will be done. After done also that working stresses, we can call them sometimes working stress. We are applying some works while we are performing. Once work done also there will be the work stress present in the machine. Technically we can call them as a residual stresses. Residual stresses means these are the residual stresses. So even though we are after conducting the work, once the work done, there will be the leftover loads or leftover pressure and leftover forces in the machines. So some work stresses also present in the machines that we can call them as a residual stresses. Hence they are present in the machine. What happens now whenever we are applying the required amount of the loads that we have already determined or predetermined or pre-selected material loads depending upon the material we are selecting the loads, that load we are once we are applying, what happens already there will be the residual stresses present in the machine, the around about 2 joules, 3 joules, 4 joules, 5 joules, up to 5 to 6 joules already that will present in the machine. Once we are applying something amount of the joules, so for example now you are applying the 164 joules, we need to apply as per the procedures, as per the type of the material, we need to apply 164 joules over the machine. But already that is the, this is what about the as per the standard formation, as per the standard ISTM standards, which we can apply the exactly 164 only. But what happens already the residual stresses are also present in the machine now, around about 4 joules already residual stresses present in the machine. If you are applying 164, what we will consider, only 164 we will consider while calculation. But once we apply this 164, also there will be the 4 percentage of or 4 number also 4 joules present in the residual stresses. Now how much it is? 164 plus 4.
168.
168, it will becomes 168, but what exactly we will take while the calculation, we are at the time of the calculation we need to take only 164 because we are applying the 164 as per the procedure, as per the standards. But the residual unexpected unexpected loads are also presented here in the machine, but hence it becomes 164 instead of 164. Now we are taking the 168. Immediately it will be but while we are calculations or simplification, that will show the sometimes it will show more low more values, sometimes it will be the less values. So this is not a proper procedure and proper way to conduct the experiment. Now we need to set this machine should be shown in 0 value. Now we make ensure that this machine is free from the residual stresses. Be careful, it's very important. It is a technically, so when once you become an engineer, so suppose you are working on these things and these areas, you have to have these knowledge, very important. Calibration of the machine is very important. Unless we are not doing all these things directly coming and conducting the experiments is not a matter. The matter is here we need to make ensure that before conducting the experiment we need to check out whether the machine is proper in condition or not. Then we need to check out the residual stresses are present or not, because we are not a god. We don't, whether unless we are not conducting the experiment, we don't know how can we come to know whether the residual stresses are present or not in the machines. That's what the things we make ensure this machine should be at 0. And so then what we will do, sir? Simply don't insert the workpiece. Just you can release the pendulum, rise the pendulum, and launch it at to a required degree. If you are conducting the ISO test, then you can take your pendulum up to. So ISO test just 90 degree you need. If it is Charpy, we need to rise the pendulum 135 degree. Yes, this is the here. This is the degree of the pendulum is also very important. Right, we need to rise. Suppose it is in so horizontally or perpendicular. If it is exactly perpendicular to the column, that we can call it as a 90 degree pendulum. Suppose this pendulum is coming like in this form. Suppose we are rising from 90 to 100 and 100 and 130. So if the pendulum is goes on increases, definitely the potential energy will be increases. So in for Charpy test, we need to rise the pendulum up to 135 degrees. Right? If it is IJOT, we don't need to go for 130. Just the 90 degree of the pendulum is enough. So here this is not exactly 90 degree. You make ensure this because of this IJOT test. So you make ensure this pendulum should be perpendicular to the column, which means now we are setting the 90 degree without putting the machines, because we need to calibrate. We need to set the machine in 0 conditions. That will not show any residual stresses, that will be show the 0 only. So without inserting the samples, just you can rise the pendulum, so which experiment you want to conduct. That particularly based on that experiment, you need to take the angle of the pendulum. Suppose it's the IJOT test, you need to ensure the pendulum should be 90 degree without a sample. Just release the pendulum. Once you release the pendulum, definitely if there is a residual stresses stresses present in this machine. If the residual stresses present in the sample, definitely that will be shown like this. Here this will be the one division is equal to 2 joules. Right, the one division is equal to 2 joules. Suppose it shows the more than one, I think it is, or not more than one, just it is from this is 0. Suppose this will showing like this here, or sometimes it will show like this. If exactly shows the second divisions, which means there are 2 joules, this is 0. Definitely this pointer will show the 0 only. If it is show 0, then you can understand there is no residual stresses present in the sample. Suppose you are this is the pendulum. If it is there, definitely that will show somewhere in the divisions or middle or exactly the one division. One division is equal to 2 joules are present. Suppose it shows the one division. If the pointer will shows, so when we are not placing the sample, just we are raising the pendulum, just we are releasing. Now it shows the one division, which means the 2 joules already present in the machine. That is what residual stresses already present in the machine. Okay, you can note it. You have to note that. Yes, one division you have to note, which means 2 joules are already is there in the machine. You note it. Then you can take the 164 joules. Or else, so let or else 164 or else anything else you can they based on the materials that this will be the changes. Then now you can so place the sample, then you can release the pendulum. Now after placing the sample, you just release the pendulum. That will show, because of the we are placing the materials, definitely that material will absorb some energy. That absorbed energy we can able to see here, somewhere at here. Suppose it shows the here. Now you can count. This is the 1, 2, 3, 4, 5. That's the 5 divisions. That pointer will show at 5 division 5, which means 5 into 2. The 10 joules we can take it to 10 joules. So 10 joules initially how much it is? The residual stresses how much present it is? Already there will be the residual stresses present in the machine. How much that? One division is equal to what? Am I audible? Hello?
Yes, sir.
Yes, sir.
Yes. Already there are two. Already this already without sample we are releasing. At that time this pointer of the pendulum will show the one division. So that is 2 joules. Now we are placing the sample. Then you can release the pendulum, same degree pendulum. Now this will show the 6th division or 5th division. So 5th division means 10 joules, right? Initially it is a 2 joules. Now you need to remove the 2 joules, means 10 minus 2. Now exactly how much? Because already 1 division plus 4 division, it becomes 5 divisions. Right now, which means
Okay.
now it is, yes, now it is 10 joules. So 10 is equal to 10 minus 2. X minus Y is equal to, that is what actual energy absorbed by the material. That is equal to U. X minus Y is equal to U. X is the residual stress value. Y is the energy absorbed by the material is equal to U. U is the total energy absorbed by the material. So X is already 2. Sorry. So X is the absorbed energy. Absorbed energy is 10 minus Y. Y is the residual stresses. 10 minus 2 is equal to U, means 8. U is equal to 8 because 10 minus 2. Minus is a residual stress already present in the machine. Now we need to remove that. Hence we will get the accurate energy absorbed by the material. Hope you understand this. Yes, this phenomena we can call it as a loss of energy due to friction. This we need to calculate. And also we can call it as a this phenomena we can call sometimes calibration phenomena. I will give a best example for this process. So whenever you can go to the Kirani shops, general stores, right? So in general, this you might have experienced this. So just you can buy a kg of sugars or salts. So just you can absorb that the shopkeeper is what he does. That the shopkeeper while we are collecting the sugars or when we are weighting the sugars, well sugar or salt. What he does exactly? Before putting your sugars or your salts over the machine, so he definitely, so he need to make sure that waiting machine should be zero, right? You might have observed or not.
Yes, sir.
Yes, sir. So what he does is before placing your quantity of the sugar or salt, before that he need to check the machines and he make ensure that that should be zero. Sometimes that will show the minus errors or means negative errors or positive errors. If it is a positive error, definitely who will be the loss? The machine has a positive error, so who will be the loss? Huh? Already that machine shows the plus 2 grams or 5 grams. Suppose we are asking 1 kg of the sugar, machine shows the already plus 2 grams already. So we are nothing we are replacing over the machine. That machine will show the plus 2 grams. Now how much we he need to put to make ensure 100 kg?
102, sir. 1000 not
Huh?
2. 1002,
1000
sir.
not plus is there. Error will be the plus.
So 998.
As 9
98.
9 90. Who will be the last now?
Sir?
Shopkeeper will be lost or that the
Sir,
customer.
we are last, sir.
Yes, we are lost because already the machine is in the
Sir, customer
positive.
is last.
Yes, customer is lost. Suppose the negative error, who will be the loss?
Salesman.
Salesman or
Sale.
shopkeeper will be under loss. Right now, because negative 2 grams is there. First, then negative is there. Then you need to make sure that in positive means 0. Then after, so we need to fill the 100 kg. Definitely 100 kg or 1 kg. So 1 kg consider this. Definitely, if it is a negative errors, definitely shopkeeper will be come under the losses. And suppose it is a +2 error, so we customers going to loss. That's what no loss and no gain. So we make sure that machine should be in a zero condition. Here also same case. Here also same case. That's what we need to remove the frictional losses in the material. That's what we just without placing the samples, we need to raise the pendulum and release the pendulum. Suppose it will show that value, any values, you can note it, then you can subtract or minus that value into the overall energy absorbed by the material. That's one case. This is very, very important. Now coming to the second step only that I will deliver. This is what 4 joules. This is the what it is, just friction losses conducted by adjusting the pointer of 164 joules and hammer attached to the pendulum raised by the operating the lever without keeping the specimen. So without keeping specimen, this will shows the 4 joules. After keeping the specimen, just release it. Suppose that will show the 10 joules. Now 10 minus 4. Exact or accurate energy absorbed by the material will be 6. So this you make ensure this calibration or friction losses. That means 25 will be on the. Am I audible? Hello, am I audible? Yes.
Yes, sir.
So only this will be the inside the machine and only the 25% or 25 mm will be the exposed to the pendulum pointer. So here there will be the notch. Sometimes we can call it a groove or notch. Now this notch is opposite to the face of the applied striker. Right. Okay. So I would like to explain through this. Once you making sure all the machines and once machines will be in zero condition or calibration is over, now you can select the material, keep in this directions. Now this will be the opposite to the face of the striker. So in a pendulum we have a, so at the inside of the pendulum, so here this will be the pendulum. So this pendulum will be hit the workpiece. So there will be the head of the pendulum here. Inside there will be the strikers. You can call them as the strikers. That one type of the striker is flat, another, whereas another type of the striker is also available. That is the point edge. So here in the ISOR case, we don't want a point edge. We need the flat edge. So the flat edge means it just look like a knife sharp. Have you seen the knife? So that edge will be, the edge means that look like a knife, so knife sharp. So once we release the pendulum, that so that sharp edge will be hit this workpiece through this notch. Once we release the pendulum, immediately that impact load or sudden load is to hit the workpiece. The pendulum is not directly hit. Inside the pendulum there will be the striker. Two types of the strikers are available. One which is pointer, other one is a flat edge. The flat edge is just look like a knife. Now the knife will be, knife type of the striker will be hit the workpiece. Now the workpiece will be the break. So here we are showing the break. Once the striker will be hit the workpiece, that workpiece will be break like this. Right now, once the workpiece will be break down, now you can take the readings here. So this pendulum is initially it was in 0 or it is in 0 it is. Now once we release the pendulum, so you need to raise the pendulum at this stage. In ISOR test you need to raise the pendulum 90 degree. Striker, flat edge. All these arrangements you need to take care while conducting the experiment. The first step is to select the workpiece, then you should just move towards the machine. Then you can, accordance to the experiment, if it is ISOR test, then you can raise the pendulum to the 90 degree. Then you can release without the specimen. Note down the residual stress values. Then you can place the sample. That if it is the ISOR test, the sample will be placing vertically in the machine. The sample will be placing vertically in the machine. That 50 mm will be inside the machine and only 25% will be the outside the machine. That notch is directly faces to opposite of the striker face. Then you release the pendulum. Here we have a striker. So here we are placing the vertically the sample. Once you release the pendulum, this is the lever. Once you, with the help of the lever, just you can release the pendulum. Now the pendulum is suddenly hit the workpiece. Right now that striker is hitting the at the exact point of the notch of the specimen. Now the specimen is immediately cracked. Then we can able to read the values in the dial indicator. Now the pointer will show some values. Then you can note down that divisions, that one division is equal to 2 joules. Suppose it shows the 5 division or 6 divisions. Suppose it shows the 6th division, it will be the 12 joules. 12 minus, if you got the residual stresses without applying the sample, definitely you got some values. You can subtract their values into the 12s. Now if it is 4 minus, so 12 minus 4, so hence it becomes 8. Now 8 will be the absorb energy from the sample. Right now these are the calculation that I will tell you. The calculation is very simple. So formula for the calculation is this. So U divided by, so applied force, you know very well U. So the final formula of the impact test is U divided by A. So here there will be the different formula they are giving you. Our formula is very simple. U divided by, just you can note it. So U divided by A. U is the absorbed energy. Impact strength is equal to U divided by A. U is the absorbed energy. A is the area of the specimen. Area of the specimen, how much area? Now you can calculate, because the square rod having the this is a square rod having the thickness of 10, which means all the sides are 10. Now what will be the value of, what will be the area of this sample now? This having the thickness around about 10 mm and all the sides are 10 mm. Now find out the area of this sample. How much it is?
10 into 10, sir. 100.
10 into 10, 100%, 10 into 10, 100. Yes, but 10 into 10, it will be the 100, but you don't take 100 because that will be the overall area of the sample. If you overall area of the sample, so you don't take that overall area of the sample. You need to take the effective area of the sample. Why? Because already we have been removed the 2 mm with the help of the hexablade, right? Why? Because that fracture is takes place only into this direction. If you are not making a groove, that one stroke and a single operation, that material will not break. How many times if you want to take, we need to break the material in a single stroke because it is time dependent experiments. We need to finish 2 experiments within the time, hence we need to break the samples in a first trial only. Or else what happens, you need to conduct the experiment number of times, and also you need to choose the materials, or you need to collect the different new samples, because the once used sample we cannot use again, because that will be affected by some loads, that will not give the correct result. So this is all these things, depending upon all these criteria, now we make that the sample becomes weak by removing the 2 mm. Now once you are removing the 2 mm from the sample with the help of the hexablades, now it becomes 8 mm, because from here the 2 mm is groove, means 2 mm is already gone. Now what will be the remaining, or how much the rest of the 8. Now you can yes, 8. Now we are remaining is will be 8. Now you can take the effective thickness or effective area. Effective thickness will be the 8 mm. Now the effective area will be the 8 into 10. 8 into 10, how much it is now?
80.
80. Now 80. U is, assume it is U absorb energy. Absorb energy, sometimes it is 5 divisions, 6 divisions, 7 divisions. If it is a 7 division, 14 joules. If it is a 5 divisions, 10 joules. So you can take that 10 or 12 joules, then you can subtract into the frictional losses. Frictional losses, if it is frictional losses 2, then 2 minus 12 will be the 12. If it is frictional losses 0, y value is 0, then no need to calculate it. Y means 0 means 0 it is, what we are observing the absorption energy is finally, that will be the correct. Okay, if you have any residual stress present in the machine, that you can substitute in the, or you can minus it. So you can take that 2 mm in the overall energy, that will be the U divided by cross sectional area of the sample. Cross sectional area will be the 8 into 10, and absorbed energy, assume it is 12 joules. Now hence it becomes joules per mm square. 12 divided by 80 or 10 divided by 80, like that. Once you simplify this, you get something value, that will be the impact strength of the given sample in terms of joules per mm square. I hope you understand about this procedure, right? And here there are different parameters we need to make ensure. What are those? So one is, if it is a IZOR test, that the first step is to select the workpiece. The total work, very important, at the time of the examination we are keeping you 2 samples in front of you. We are keeping the 2 samples, that one has a 55 mm length, whereas other has a 75 mm. So as per your question, as per you need to conduct the IZOR test, then you need to select the which sample has a total length of the sample has a 75 mm. That will be the suitable for the IZOR test. Total length of the sample will be the 75. Then you need to make a groove, but in examinations already prepared samples we will provide you. Actually procedure is that you need to prepare the sample. You only can prepare the samples. You can collect the sample, you can go for the workshop and you can select the square rod. Select means available square rod is there, then you can go through the workshop and take the hexablades, and you can cut the samples as per your requirement. Then you only can make the grooves. But this all things will not happen within 3 hours. This will be the very difficulty. When in practice laboratory we can take this, but when we are coming to the examinations, it is time dependent, so hence we will not allow you to prepare the samples. The prepared sample we will provide you at the time of the examinations, right? The prepared samples are available in front of you, so depending upon the questions, you need to select the samples, whether IZOR or Charpy. IZOR 75 mm length, Charpy 55 mm length. That is first step. Second step, friction losses you need to determine, Third step, you need to place the samples as per the ISOT test. Vertically you need to place, and this will be the pace will be the opposite to the striker pace, right? Striker, what kind of the striker we need to take? Here two types of the strikers are available. One is the uh, point edge, other one is the flat edge. Which one you need to take?
Point
Flat
it.
edge. Not point. Point means just like a tip of our ballpoint pen. We don't want such kinds of. That is the Sharpie test, because yes, flat edge. That point edge we need to take for the Sharpie test. Why we need to take the point edge for the Sharpie? I will explain the later next class. But this class, because this also this is the groove is there, no? This groove is there. This groove we need to, so we need to take the flat edge or knife edge. Knife edge will be fixing to this groove, and that will be hit the workpiece. Now in this direction, workpiece will be the bent. Now the pendulum, angle of the pendulum, how much for the ISOT test? Angle of the pendulum, how much?
90 degree.
Yes, 100%, 90 degree. So we need these. These are the important things. Angle of the pendulum, 90 degree. Striker, flat edge or knife edge. Placing this sample into the machine vertically opposite to the striker pace. Then the groove depth 2 mm. Total length of the sample 75 mm. Right? If you know all these things, you does mean that you are conducting the experiment. Yes, sir, definitely. So now we'll go for the simulations. Right. Yes. So the selection is mild steel material, because obviously we will take the mild steel material. Just click on the mild steel material. Yes, the mild steel material 75 mm. Here you can able to see. As I told you that, so 75 mm, because it's the ISOT test. Now we need to take the total length of the sample will be the 75 mm. So but 9.3, 9.4. So around about 10 it is exactly it is. So approximately they are taking 9.39. Think that this will be the 10 into 10. That's 10 into 10 is the best for us. So 10 into 10. Now the depth of the notch they are taking 3.34. Right. So how much we need to take for our laboratory? Depth of the notch
2 mm.
2 mm. Keep it in your mind. So in our laboratory we need to take 2 mm. Yes, this will be the 10 and 10. This is 75. This is 10 and this is 10. This is 2. Right. Now next. Yes. Now I am click on this lever button. Yes. What is this? Yes, what is this? What is the second step? Huh?
Impact load.
Okay, yes, it is impact load.
Release.
What will be the next step? Second step. What it indicates?
Releasing pendulum.
Yes, releasing the pendulum without placing the specimen. Yes. Now without spacing the specimen, now we are releasing. Yes, without spacing the specimen, now we are releasing the pendulum. Now we will got 2 joules. 2 joules means it is operational losses or residual stresses present in the machine. Yes, note on this. This value is now y value. It is right. This y is equal to 2 now. Now we can note on this value. This will be helpful for our next step. Now the placing of the sample. So this is for trial. Now we are placing the vertically. Then the 50 mm is into the machine. We will not see that. That will be gone into the machine, and only this portion will be exposed. Only 25 mm will be exposed. Exactly the notch will be is level to the platform. This will be exactly level of the platform. Then that line key also available. You need to check this platform level and this notch level should be matched. Now they are showing the little bit upper than this, but when before conducting, so this notch should be level of the platform. then only you can release the pendulum. Now once we release the pendulum, this is the flat edge. Now they are showing the point edge. Now it is a flat edge actually. This flat will be hitting this portion. Now the workpiece will be break like this. Right, now going to the next step. Yes, this is I am able to show you. Yes, like this. See, as I told, this level of the platform and notch level will be both are in the line. Right now. Yes, is it visible?
Yes,
Both
Yes,
are
sir.
in the yes. Then only you release the pendulum. Otherwise, you don't release the pendulum. Yes, the notch level and the platform level should be in. So in the only in the line, they are both are in the same line. Now we are placing the pendulum. Yes. Now the work is once we release the pendulum, now that material is brought down. Once the material is brought down, that automatically the machine will read the values. The total loss of energy during the transit of the hammer is 41 joules. Now how much we got? 41. Now what will be the 39? But it shows 41. But the energy failure of the specimen is 39. Why?
2 joules.
Ah,
minus.
yes, minus 2 already present in the machine that we need to subtract into the total energy. Hence, this 41 becomes 39. Now, the 39 will be the exact energy absorbed by the specimen that need to break. Right? At this level, that material will be a break. Yes, I hope you understand now. Yes, the initial energy of the hammer. This is the calculation. This will not part of the calculation. For the information purpose, the hammer weight will be the 164 joules, and average loss of energy friction is equal to 2. Right? That definitely they are asking you the what will be the what will be the weight of the pendulum. Weight of the pendulum will be 164 joules, and average loss of the energy due to the friction that we can call it as an residual stress present in the machine will be the 2 joules, and total loss of the energy during the transit of the hammer is a 41. So 41 we will got once we paste the sample and release the pendulum. So after the simplification or subtracting that friction losses, we will get 39. Then next step, this is what next step. What we need to find out the impact strength. Impact strength will be 39 divided by this 39 divided by cross sectional area of the sample. Cross sectional area of the sample, how much it is?
80. 100.
No, 100. Be careful because already
80.
2 mm is gone through the
80.
notch.
80,
80.
sir. 80.
Now 39 joules divided by 80 mm square. Now we will get the correct or exact impact strength of the given sample. Yes. This will be the trial 2. So trial 2. Now we are placing the sample. The answer size will be the same. Now once we release the pendulum, see how the workpiece will be the break. Right. Now we will got the yes. Again the second trial we will get so 2 joules indefinite. So there will be the something issue. Don't want the second trial. One trial is enough for us. Third trial, if you want to take, you can take it. No. So why it is indefinite? Because that workpiece will earlier was that workpiece will not completely break. That's what that will not show the values. Now the workpiece will completely break. So hence this will show the 48 joules. Then the 46, because 2 mm is reduced. No, hence we get the 46. Then you can put the calculation. Hope you understand. The first trial is 41, second is 48.
Yes,
then after the yes, now 39, 46. Take this 39 divided by 80. Take this 46 divided by 80 mm square. Hence we can get the impact strength will be the joules per mm square. Hope you understand.
sir.
Okay, sir.
Yes. Now I will take the attendance. Just wait a minute. I will take attendance. We will finish up this lab. Tomorrow we will discuss the Charpy test. Okay.
Yes, sir.
Okay, sir.
Yes, sir.
Thank you. Welcome.
Thank you, sir.
Welcome. Yes. Now you can take the
Okay, sir.
meeting. Oh, now you can do the meeting.
Okay,
Thank you,
sir.
sir.
Okay, sir. Thank you, sir. Allappa Jarkiwale.
ಲೌಡೆ ಲೌಡೆ
ಏಯ್ ಕ್ಲಾಸ್ ಇದೆ, ಏನ್ ಮಾತಾಡಕತ್ತಿ ಮಗನ? ಮಲ್ಲಿಕಾರ್ಜುನ್ ಅವ್ರೆ ನಮಸ್ಕಾರ.
ನಮಸ್ಕಾರ ನಮಸ್ಕಾರ.
ಇವತ್ ದರ್ಶನ ಕೊಟ್ರಲ್ರಿ ಮಲ್ಲಿಕಾರ್ಜುನ್.
ಹಲೋ ಹಲೋ ಮೈಕ್ ಟೆಸ್ಟಿಂಗ್ 1 2 3 ಕರೀನಾ ಕಪೂರ್ ಕತ್ರಿನಾ ಕೈಫ್
ಸೊಲ್ಲು ಬೈ ಸ್ಮಾರ್ಟ್.
ಪ್ರಿಯಾಂಕಾ ಚೋಪ್ರಾ
ಸಲ್ಮಾನ್
ಸಾರ್ ಹೋದ್ರೇನಾ?
ಹೋದ್ರಲ್ಲ ಕಳ್ಸಿದ್ವಿ.
ಹೌದಾ?
ಏನ್ರಿ ಮಲ್ಲಿಕಾರ್ಜುನ್ ಇವತ್ ಬಂದ್ರಿ ಕ್ಲಾಸಿಗೆ?
ಬಂದ್ರಿ.
ಹಾ ಹೇಳಪ್ಪ ನಿಖಿಲ್.
ರಾಘವೇಂದ್ರ ರಾಜ ಅದು
ರಾಘವೇಂದ್ರ ಏನ್ ಫುಲ್ ಜೋರ್ ಅದಾನ, ಮ್ಯೂಟ್ ಮಾಡ್ಕೊಂಡು ಹೋಗ.
ಮಲ್ಲಿಕಾರ್ಜುನ್
ಹಾ
ನಮ್ಮ ಆರಾಮ.
ಎಲ್ಲ ಆರಾಮದೀವಿ, ನೀವ್ ಆರಾಮಿದ್ದೀರಾ?
ನೋಡು ದೀಪ ನೋಡು, ಗೊತ್ತಾಗತ್ತಿಲ್ಲ ಹೆಂಗ ಎಷ್ಟು ಆರಾಮ ಅದಾನ ಅಂತ ಹೇಳಿ. ಹಾ ಹೇಳಪ್ಪ.
ಏನ್ ಬರ್ಕೊಂಡಿವ ಸಾಕ್ಷ್ಯ
ಯಾವ್ದು
ಸಂಸಾರ
ಒಂಚೂರು ನೋಡ್ಸ
ಒಂದು ಯಾಕೆ
ಗ್ಯಾಪ್ ಆಗೈತೆ.
ಏನ
ಗ್ಯಾಪ್ ಬಿಟ್ಟಿನಪ್ಪ.
ನಾವು ಬರ್ಕೊಂಡಿಲ್ಲಪ್ಪ. ಆಕ್ರಿ ಇವತ್ತು ಬರ್ಸಿದ್ದು ನಿನ್ನೆ ಬರ್ಸಿದ್ದದ ಹಾಕ್ತಿದ್ರ
ಹಾಕೋಣ. ಏ ರಾಜು ಮಾತಾಡು.
ಫ್ರೆಂಡ್ಸ್ ಬಾಯ್.
ಬಾಯ್ ಬಾಯ್.
ಹುಲಿಗೇಶ್
ಲೇ ಅವನು ಕೇಳದ್ ಬಿಟ್ಟು ಮ್ಯೂಟ್ ಮಾಡಿ ಹೋಗ್ಬಿಟ್ಟಿರ್ತಾನ ಅವನು ಹುಲ್ಗೇಶ್. ಅಂಗಡಿಯಾಗ ಕುತ್ಕೊಂಡಿರ್ತಾನ ಅವನು.
ರಾಘವೇಂದ್ರ ಮ್ಯೂಟ್ ಮಾಡೋಣ.
ಎಲ್ಲರೂ ಮ್ಯೂಟ್ ಮಾಡಿ ಮಕ್ಕ ಮುಟ್ಟಾರನಪ್ಪ, ಅದಕ್ಕೆ ಏನ್ ಗೊತ್ತಾಗಲ್ಲ.
ಯಾರಪ್ಪ ಅದು? ನನ್ನ ಹೆಸರು ಹೇಳೋರು.
ನಮಸ್ಕಾರ ಗುರುಗಳೇ.
ನಮಸ್ಕಾರ.
ಏನ್ ಫುಲ್
ಸೈಲೆಂಟ್.
ಎಕ್ಸಿಟ್ ಆಗ್ಬಿಟ್ಟ ಅವನು. ಮತ್ತೇನ್ ಸಲ್ಲ ಬೈ, ಊಟ
ಆಯ್ತು ಬೈ, ನಿಮ್ದು?
ಇಲ್ಲ ಬೈ, ಈಗ ಮಾಡಕ್ ಹೋಗ್ಬೇಕು ನೋಡು.
ಫುಲ್ ಬಿಜಿ ಕ್ಲಾಸ್ ಕೇಳೋದ್ರಲ್ಲಿ.
ಏನ್ ಮಾಡ್ತಿ ಬೈ, ಪಾಸ್ ಆಗ್ಬೇಕಲ್ಲ ಬೈ. ನೀವಂತೂ ಪಾಸ್ ಆಗ್ಬಿಟ್ರಲ್ಲ.
ನೀವು ಫೇಲ್ ಆಗಿದ್ ನೋಡ್ರಿ.
ಏನೋ ಬೈ, ಅದೇನು ಪಾಸ್ ಆದಂಗಿಲ್ಲ ಬಿಟ್ಟಂಗಿಲ್ಲ. ಬರ್ಲಾ ಬೈ, ನಮಸ್ಕಾರ.